Okay, so the talk's title is Wolf of Wall GPU Profiling and Tracing Street. So, what does come to your mind after reading this talk's title? Tom Cruise? No. Annabelle? No. Mr. DiCaprio, right? So it was just to add a pinch of fun and humor, but you didn't laugh, so my joke went wasted. So, what's the most valuable thing that Mr. DiCaprio talked about in the movie? It was cash, right? It was money. It was green cash. So, the green cash in today's scenario is GPU. Okay, the most expensive thing that one can really afford is GPU. We all know about NVIDIA's stock price. Now it's plunged, but everything the GPU and AI race. So we all know about that. And one thing about GPU is that, okay, I misclicked. Okay, that every minute counts. That is the agenda of this talk, that how to make your GPUs count every minute. Okay, every minute of your inference pipeline, every minute of your training pipeline, every moment your product is up, you need to make that minute count. Now, let's go. Again, you had to laugh. So, Rejects describe the speaker. I am the CTO of Cube Cloud and InfraOne. I don't like to actually promote my company in events, but this is how our company looks like. We have a couple of tools in the cloud native space. We have Sketchpad, so you can actually design your architecture. Okay, this is the free version, so you can actually design your architecture, and my products do have working live demos, and you can easily get the Terraform code in the, okay, it's not working, just kidding, my internet is not working. So you can actually just we have a lot of tools. So Sketchpad, Lemon is a cost optimization tool. Headlight is more of again, things are not loading because of my bad internet connectivity. Headlight is a tool for actually modernizing your documentations. We have Nuts and Bolts, which is an automation center. You can, in no code, you can actually automate any kind of stuff. We are still building, so if you really want to join, do join us. And in InfraOne, which is a sub company, we are actually building AI suite for observability. So 4 agents, one for monitoring, one for logging, one for profiling, and one for tracing. This particular talk is a case study about the product that we are building. It is not a theoretical talk or not actually a talk that I'm reading from a notebook or some textbook. It is real life scenario. Coming back to my slides. My name is Prerit. I am the CTO and co-founder of CubeCloud.tech and InfraOne.io. I love adventure in all sense. Do you know what this stone is? Anybody knows? Yeah, Stonehenge. So I went there yesterday. So it is lovely. You should actually go there. And so do you know the reason of Stonehenge? No? So prior to going to Stonehenge, I thought that, okay, humans wanted us just to tell the future us that we were there in the past, right? So they were just actually telling their significance. But these stones in the Stonehenge actually say, tell you about the time, the seasons. So you can actually see sun going. There are 4 seasons, right? So you can actually go and see the sun going from one stone to the another. I love adventure in all sense, so I just went for a skydive, and it was lovely. I run a YouTube channel, Tech with Prerit. We have the most viewed Kubernetes series in Hindi, which is a regional language of India, in 2024. I like to write a lot of glue code because that's what real engineering is. On an average, I get 13 million plus eyeballs on LinkedIn. So yeah, eyeball is pretty scary. So on LinkedIn, so if you need any help about content, about lifting your LinkedIn, free of cost, again, friendly advice I can give you. So coming to the agenda is pretty simple: when and what, why, how, and what head. Again, agendas are pretty simple. First we talk about the problem, then we talk about the solution. So prior to starting this talk, I just want to say that day one is not meant for optimization. This is a story. This is our real story. So we actually optimized our infrastructure on day one. The reasons are the following slides, but you shouldn't be optimizing on day one. Just after hearing this talk, you just go to a CTO and tell that, okay, that guy did some profiling on their GPU inference pipeline. I just want to do that. Some backstory. This is the reason. Actually, we were hit by a crypto mining attack on January 2024, which costed us over $1 million. And the video is on HashiCorp's YouTube channel. Do you want to know about this attack, or should I continue? Yes? Okay. So very short talk because I'm already running late. So in January 2024, we had a B2B deal. What we do actually, prior to dealing with cloud native stuff, we used to have multi-tenant platforms. So we used to offer sandbox environments to the end user, and what we were doing was we had a lot of Google Cloud projects. We used to flush them, we used to renew them, and then we used to give them to the end user. So users could actually come in, use our email ID, like your name is q@qcloud.tech or qcloud.org, and you could just spin up your sandboxes. So one of our client came in, they booted up the maxed out virtual machine. So they were very clever enough. They actually figured out. So one thing to note here is we used to do cleanups in Google Cloud with shell scripts. Okay, so every moment when the sandbox ended, we used to boot up a particular shell script based on one particular set of regions, because there are a lot of regions in Google Cloud. Our infrastructure was just meant for US Central 1. So the crypto miners actually came in. They figured out that, okay, these guys just have the shell scripts in the US Central 1. So like they had 10 days of pre-workout before actually doing the stuff. So after that, they came on one weekend, and they actually, so it was mid kind of 20th, because our billing alerts are approximately 80% on the 20th kind of thing. We had a couple of alerts, but we thought that, okay, it might be because we just cracked a couple of deals, so it might happen that they are overusing the product. So we actually took it very leniently, and the next Monday, then when we woke up with a $1 million bill and a notice from Google Cloud that they're suspending our Google Cloud account. So technically we were doomed. We had nothing. We had nowhere to go. But again, then we actually did some root cause and RCA, and then we figured out how they actually did. So they booted up a lot of big machines. They took the RDP access, and then they started the crypto mining thing. The next thing, there are 23,000 plus metrics in Google Cloud, and in any cloud, in AWS, in Azure, we have over 20,000 or 25,000 metrics according to each zone, each region, and each service. So technically it is not possible, because we were a very highly multi-tenant kind of platform. Technically it was not possible to tweak the organizational policy, because it would have affected all the sub projects. We wanted to be a very customizable kind of metric platform system, so we used Terraform. Terraform has actually a beta feature which you can actually use to customize your particular metric. So it took about 2 months, and we actually did that particular stuff. For that, we were invited to HashiCorp Sydney to present this use case. I highly recommend you to watch this particular video. Now, this was our chat. Again, these are AI generated. These are not reals, because we used a lot of cuss words. So I didn't want to blur or after this attack, we were actually going to launch this AI suite thing. Okay, so we were trying, because AI race in 2024 was good. People were actually building vertical agents. People were building a lot of things, wrappers, a lot of things on top of foundational models. So we also thought of actually building some stuff, and finally, we got some GPUs, because in 2024 things were really hot in the GPU space, and because I have a good LinkedIn, so we got some GPUs from Google Cloud and on-premise, some of the providers. So the next thing, we were secured with GPUs. I told you what we were building. The next thing was we wanted to be damn sure, because prior to building the agents, we already had a $1 million bill in our accounts, which Google Cloud actually waived off. They were very, very generous in that, because anyway, we are a startup, and no startup can afford $1 million in cloud. Will not even, I think good enterprises can afford that. Instead of paying $1 million to a cloud bill, you should actually go and buy a good data center. So the next point was, we wanted to be very sure that we are observing the agents, and the similar thing don't happen to the AI agents that we are building. So we had to be very, very secure with the observability. And when we went to the CNCF landscape, we were really, really shocked, because observability, Ollie, is the most trending topic in CNCF. So even there are, I think, 100 more tools which are not even registered by Google Cloud, by CNCF, and still a lot of tools, but none of these tools can actually do anything with GPUs. So there is no tool in this CNCF ecosystem which can actually do the GPU thing, which can observe the thing. Ideally, GPUs and CPUs are same, but in terms of profiling, they are much different, because underlying technology is very, very different. We'll be coming to that part as well. So we had to also, we had a prior good experiences with many enterprises where, like, I can't name them, but they build for every single thing, egress, ingress, every kind of thing. So we were also not in the financial capacity to go for a enterprise deal. Okay, so this is our architecture. Okay, so we use Pixie, which is an eBPF based monitoring tool, to actually observe our services, to monitor our services. We have OpenTelemetry for tracing, Loki for logs, and Pyroscope for profiling. So we wanted to be very lean in our cloud tooling, or CNCF tooling, or open source tooling. Our infrastructure is primarily based on GCP and some of the on-prem servers that we have. And yeah, this was it. So this is a pretty. So do you know what is inference means? Do you know? So it is a process when you tell the LLM to give you something, and the process when the LLM gives you the output, that process is called that. And this is a simple pipeline where we used Redis queue to store the inputs and give the outputs. Now the problem here was, on day one, not on day one, but month one, there were actually a lot of failures. And also, I'm not a GPU expert, and nobody here is, because first of all, GPU came in the boom when we were not ready, right? There are very limited architectural deep dives. We tried a lot of documentation, but couldn't find any. And also, we had a problem of inefficient batch processing. We already had 50K in cloud bill, which was actually kind of what we were expecting in the middle of building. So we had one pivot. So in the previous ideation phase, we were actually thinking of building a foundational model just for this troubleshooting and observability stack. Then we saw Claudes and a lot of other, even Mistral AI. Now Mistral AI is launched, but at that time also we had something. So they were very good in actually doing the troubleshooting after just fine-tuning them. And also we had some kind of, it was costing us $1.2 per million tokens. I can't recall, but it was quite huge. And we also didn't have any clue in the latency breakdown. We were just running in the wild. Okay, so we had no metrics. We were just relying on the GPU on the GCP's entire observability stack. It has, I think, OTel integrated into it. So the need here was to have CPU level observations. We used Go in our backend, so we wanted thread as well. We wanted Go routines as well. We also wanted, because in the problem we were not having actual clear error messages. Though in logs you can actually go and see what things are not working, but logs are not meant for that, not actually meant for that. Okay, so logs is just your history, right? So it doesn't have that technical deep dive of what things went south. So we wanted to have things regarding memory, things regarding logs, things regarding exceptions and errors. So just to be on the same page, this is what profiling looked like. Okay, so for example, your entire day is 8 hours of work, and we segregate into 45 minutes of email, project work, meetings, coffee, and strategy work. So after actually observing, and this is the thing that activity or monitoring tracking softwares actually do. So they are going to actually create a timeline for all your activities and just stitch it into one. So here optimization opportunities is that reduce meeting time by 15 minutes. And you shouldn't be spending a lot of time on meetings, and add 30 minutes of deep work block, because right now we can't see any employee efficiency. Are we good with profiling? Yeah? Yeah. So yeah, it is another joke, but we are not going forward with it. So this is how actually profiling works. So let me play it again. Okay. So at the top we have the base function, and then we have the hierarchy. The longer the horizontally, the longer the line is, the more longer time it will take. The vertically, more nodes are there. That means the function has more function calls or more hierarchy, and it shouldn't be there. In some cases it should be there, in some cases it shouldn't be there. So totally dependent. Again, I think most of us are pretty much known to profiling. So three things that offers is: first, cost cutting; second is latency reduction; third is faster debugging and incident resolution. Because in the end you have a very deep dive view of what your products are, what your actual software components are consuming, which software component is consuming which, how many number of CPU cycles and other stuff. Just an activity, I think we have some time. So can you tell me in example 1, what things can you actually optimize? Is it visible? I think it is. Let me, I can't increase the, I think. So anyway, in example 2, what do you think you can optimize? Anyone? Okay, this is a homework. So you can optimize anything. So at the so the most recent is compute product is taking 18% of the time, and it shouldn't be taking, because the more hierarchical you go in the flame graphs, it is bad. It is bad for end user latency. And also these are some of the charts that you can like look after the session. Now the next closest thing that we actually were dealing with was Pyroscope. So at that time Pyroscope was not part of Grafana family, but it got acquired one year ago. I acquired, or they joined voluntarily, I don't know, but they are Grafana Cloud now. So when you go to Pyroscope's cloud, it will take you to Grafana Cloud. So it had everything that we wanted. So it offered CPU time, memory input output operations, and that's what we needed. It offered continuous profiling. So there are two kinds of profiling: continuous and non-continuous. Continuous is good. I still remember back in 2021 we were heavily invested in non-continuous profiling. So we used to instrument manually, and suddenly in 2022 or 1, Google Cloud actually retarded that service. So the service name is Cloud Profiler and Cloud Tracer. So at that time, we had to manually implement the things. Coming back to the topic, so the good thing is, it is, due to continuous profiling, it is not going to add that much latency to your, or CPU overhead to your particular application. So at about, like in the frequency, do you know anything about clock cycles? Okay, no, it is not relevant. Joke. Okay, I tend to keep, I tend to crack a lot of lame jokes in my presentation. So in every 15 seconds, it will be sending periodically the data to a server, and it is very, very good at compression. You can add S3, GCP bucket, and other things to store your profiling data. So very, very good tool for profiling. I don't think any tool is better than this particular tool in profiling. This is how this particular tools. Okay, there is a suspense in the end. Okay, this is how the profiling dashboard looks like. You can also have tracing into this platform. So because eventually everything is a part of Grafana family, so you can actually integrate a lot of stuff. But after instrumentation, we realized this is not enough because CPUs and GPUs are different. CPUs, you have, if you don't know how profiling works, so there is some symbol table, there are programs, there are particular set of files, like due to Linux, a lot of things are standardized. So we have a lot of files in particular format. We have a symbol table, we have a process table, but in GPUs we don't have. Okay, not actually Linux, but in CPUs, they tend to have a process table, a symbol table, due to which your that's how your profiler is going to work. But at that time we realized this is not enough. Then another tool came in, and the tools, the only tool as of now which can actually profile your GPUs is Intel Tribe AI Cloud kind of thing. Intel Tribe, I guess, AI is their add-on word. So this is the only tool which can actually instrument, which can actually differentiate between your CPU calls and GPU calls. So everything that you see in the green, they are CPU calls. The gray one, so this one, this blank line is when the system switched from GPU from CPU to GPU. So the above one are GPUs, so the blue one, and then the thing came back to CPU. Now the thing is, this is the core logic or core learning for us from that particular instrumentation is that once that execution begins in GPU, the memory might not be in even the main memory. Okay, it cannot be even in the accelerator memory. Okay, and that's the reason it can't be available to the OS profilers, because OS profile. So the thing is, in GPUs, in CPUs we have process table and other stuff, and we have taken them for very granted. In GPUs we don't have them, so there is also no proc representation of this program either in GPUs. So there, in short, there is no direct way to even tell you what is running and what isn't, and only this particular tool is very good at it. I think the only one. The tracing part is exactly the same as of CPUs and GPUs, so there is no single difference. We are using OpenTelemetry for tracing, and there is no single difference between tracing, because eventually tracing is about identifying the bottlenecks, which service is causing which, how much and which delay, and what we can optimize it further. Before we had a average GPU utilization of 34%. We have P50 of 850 ms, P99 of 2300 ms, error peak rate of 2.7%, which is fine enough. Cost per 1 million token is $1.25. After actually doing the profiling thing and doing some magic in our batch processing and in inference pipeline, the average GPU utilization went straight up to 78%. P50 went to 450, P99 to 905. Error peak rate is 0.5%, and cost per 1 million token went straight down to $0.75. But again, cost was not even 1.25 was manageable. But yes, without profiling and tracing, we couldn't have actually reduced these kind of numbers. So we also observed 0.8% of additional latency due to profiling, but 0.8% is fine enough because we were actually blind before the implementation, and after that we were totally fine with it. And also it takes quite some memory, so 2 GB per day for full trace retention. Again, in any way, if you're building any product, it is going to take some storage, and storage is pretty cheap in cloud, in any hardware world. So you can easily get an NVMe 256 gig for I think $100. That's it. And after that, we were less noobs. We had a lot of information about our particular tools. So we are actually running a cohort. So let me go back to this website. So we are actually running the cohort, and we are currently doing some beta tests on our particular tooling. So our front-end engineer is very much creative. So you can actually come in the cohort and you can actually test these tools, and we're going to open source it. So yeah, you can sign up for them. And coming back to the slides, because as of now they're pretty much good. They can troubleshoot it. They can again, monitoring and logging. I think monitoring and tracing and profiling, they should be just one click of a, like it should happen like a magic. Nobody should invest a lot of time, money and resources in just instrumenting the things. They should happen in and just click of a button. You should anyone could just click a button. Software could tell you that this is the bottleneck, this is the thing that you need to improve. So was it worth it? Absolutely yes, because before this our CPU time was quite high, due to which our resource efficiency was very less. It was costing us more, and being a startup, money matters a lot. More than ideas. So yes, it was worth it to actually instrument the things. And yeah, this was it. I couldn't do a demo because the thing is, GPUs are costly, and right now we don't have any, like everything is consumed, so we couldn't. And also there is one implication that you need to do a lot of stuff with VRAMs, with a lot of tweaking with batch requesting, batch, even the queue size, everything you have to build on your own. If you are building something very good on top of foundational models, and actually you want to be profitable in a longer run. So yeah, that was it. And I will be there at KubeCon tomorrow. I have a talk at KubeCon Platform Engineering Day and Open Features Summit, and looking forward. If you have any idea about, if you really want to build such kind of systems and you're really into it, and if you know how to build these, I would love to have a conversation with you. If you have any doubts, I would love to talk.
We have a little bit of time for one question. Anybody? Okay.
Thank you for the talk. Can you return to the slide with the Intel tool profile flame graph?
This one?
The Intel for GPU. You shared the,
this
the
one.
only tool that
Yeah.
has GPU.
Yeah, this one.
Yeah. I noticed that there is some mention of i915 something in the stack tray. Yeah, the gem do exact byte buffer thing, and that like leads me to a question: is this tool capable of profiling different GPUs or just Intel GPUs?
Just Intel GPUs.
Yes. Thank you.
So yeah, one catch. Thank you. So this tool can only, because the name is Intel Tribe, so it can only do the Intel GPU kind of thing. You can't actually implement this tool in the NVIDIA stack, and that is perfectly fine with us. So previously we had a couple of H100s and T4s, and then we opted for the Intel GPUs, and that is perfectly fine. They're even cheaper. Yeah, that's it. Thank you.